all, I am Dr. Sumitra, an Associate Professor from the Department of Computer Science and Engineering and SNS College of Technology. Today we are going to discuss all about the memory management. Memory is a crucial resource and the OS must manage it more efficiently, like that of with the static allocation and the dynamic allocation. The static allocation is all about the memory allotted at a compile time, where we can simply state that it can lacks its flexibility, whereas the dynamic allocation is all about the memory which is allotted at your runtime, allows your optimal flexibility as well as the usage, where your memory section is divided into four major parts like text, data, heap and the stack. Let us have a text is all about, we know that the text contains an executable instruction, and the data is all about it contains a global and the static variables, whereas the heap is mainly used for your dynamic memory allocation, like that of your malloc and the new. The stock is carried out for the function call and the local variable, where here your proper management avoids the memory segmentation faults and the fragmentation. Whereas the allocation deallocation is all about the basic functionality which is carried out on your memory management. The allocation and deallocation is where it assigns and releases your memory through the process, where your memory mapping is carried out with a map logically to the physical address. Here a paging and segmentation will all about that enables your non-contiguous memory usage. The fragmentation is also handled over there. There are two types of fragmentation. One is internal fragmentation and the external fragmentation. The internal fragmentation is where the wastage of the space within the allotted memory, and the external fragmentation is all about the free memory scatter. Hence, the production will help you to carry out the preventing an unauthorized access across your processor. The contiguous memory allocation, where the entire process in a single block, simply we can state that it helps to have a lesser flexibility. And the non-contiguous, obviously there is a basic categorization of contiguous allocation and the non-contiguous allocation. The non-contiguous allocation is all about, we have a paging technique, segmentation, which helps you to have a better memory usage. Hence, we move on to the basic concept where how your program must be in the memory to execute. The input queues, the queues of your process will waiting to be loaded into the memory, and the process state where your process will be keep on switches from the states like new, ready, running, waiting and the terminated. Hence, the memory is shared among your processor, so the management will ensure a firmless security and your better performance. Hence, the base and the limited register is all about the basic register. Hence, it holds a starting address of the processor, and the limited register will definitely define the range and the size of your accessible memory. Together of both these things will create a boundary for your process. Hence, if the process raise or try to access the outside this range, trap to generate a prevent error or hacking your attempts, enabling you a hardware level protections and isolation. Next, we move on to the hardware address protection. Hence, in your hardware address protection, the memory access follows your validation steps. We have generally a four major validation steps. One is the CPU, which generates your address and add your base address to it, and then it compare it with both the limits. Within a limit, your access is granted, else your trap is triggered. So, provides you the strong protections in a multiple user and multitasking environment. We move on to the address binding. The address binding is all about the process of mapping a program address to the memory address. Compile time binding. The address determines at a compile time and the fixed memory allocation. The loading time binding. The address will determine which program is loaded, and the execution time bounding. Hence, it focuses on the address computed during the execution during MMM. The MMM is your memory management unit. The execution system, the execution time bounding is most flexible and supports your reallocation.